Hi, let's talk about Conformiq software. Let's talk about our designer. It's a system for automatically thinking of and generating the test cases. And we're going to do a SugarCRM demo today. Let's take a look at the slides. Let me switch on the next slide. So what we did is we decided to do a demo of enterprise software, and we picked Sugar because it's an industry standard component. It's open source. It runs on Apache. It runs on MySQL as a backend, another standard component. And what we're going to demonstrate how Conformiq designer creates tests to test the UI elements and to test data correctness. We're going to be using two interfaces here. One is a UI interface accessed by the browser, and the other one is a web services interface, which accepts SOAP calls. And on the back end, we have MySQL database, which powers the whole thing. Let's take a little look at how the whole thing operates. We create a model of how the system is supposed to operate in Conformiq Designer, and from that, we generate the test scripts. We also generate a mapping into the test harness. In this case, the test harness is going to be powered by Selenium, another open source component, which is frequently used for UI testing. And we also wrote a little test harness for making the SOAP calls. And then ultimately, everything interacts with our SugarCRM. So that was the brief introduction, and now let's take a look at the SugarCRM itself. This is a typical main page screen. On the main page, you can see we've got links to sales, where you can click on accounts, or you can click on contacts, and corresponding pages will be displayed. For example, if I click on contacts, the system will bring up the list of all the contacts currently present in the system. Or if I go back to the main page, we can see that there are links to create contacts or accounts or leads and so on directly. So you can see as the number of links grows on the main page, the task of testing them all out correctly grows exponentially. So this is where we throw the computation power of our engine into at the task of testing the whole thing. This is a data. Now, let's get this out. 3, 2, 1. The first step is that we create the UML model of SugarCRM. As you can see, we've got our main screen, and then there are certain pages which we can access. Let's take a look at the UML representation. This is our system at the first glance. This is the start of the system. It's expressed in UML 2.0. This is our tool that we ship with our software. You can use any other UML 2.0 compliant tool, for example, Enterprise Architect or IBM Software Architect. We can interact with those. Let's take a look at the UML diagram. As the user logs in, he sees the main page. From the main page, as we just saw, you can access page with the contacts or a page with accounts, or you can go and click on the link to directly add a contact or create an account. So you can see that the system responses are represented as states. They are pages that we see. Right? And then the user interactions, something that you can do with the system, is clicks. You can click on links. So these transitions from the main screen to the pages are expressed as transitions in the UML. Let's focus on one of the transitions. Each transition is recorded as a UML standard. There is a trigger, something that happens, the user influences the system somehow. And then there is a predicate where we qualify the act that happened. And then there is an action, there is a response. Something happens in the system. You can see that some of these states have little glasses icon on them. That means there is a substate. There is another submodel running in there. For example, let's take a look at add contact. There is another submachine here. What happens when you add a contact? Well, according to the SugarCRM spec, and I say according to because really we're not touching the source here. What we do is we try to create the whole diagram of how the system works based off the spec. This way we achieve independent verification that the spec was complete, that it was unambiguous, and that it was interpreted by the developers correctly. So you can see that when we add a contact, the user can bail out at multiple points in time, and you say, okay, I don't want it to add a count anymore. I add a contact anymore. I want to cancel. And then if the user does decide to add a contact, the system is supposed to check for duplicates. And if a duplicate is discovered, then the user is supposed to see a confirmation. Do you really want to add the account that already exists in the system? And if the user presses cancel, then the whole system reverts back to the main screen. And if not, if he does confirm, then the contact is added and the results of adding a contact are displayed on a web page. And this is a fairly simple diagram because web services are typically stateless. It's just a daemon sitting and listening for requests. So when a request does come in, it is processed, and then the system returns to the original state. Obviously, we didn't model the whole set of commands available in SugarCRM. We wanted to showcase, we just wanted to show a subset that would be suitable for the demo. So here we expressed how two commands are handled, when a contact is added remotely, and then when a user searches for the contacts remotely. Now remember that these two interfaces operate on the same system that has the same backend. And we'll see how the engine figures that out and generates the tests that test the interaction between these two independent interfaces, the web browser interface and the remote interface. Now that the UML workflow is complete, we can go to the second portion of the model, which is expressing what happens in these actions. You can see again that every transition is expressed as a trigger, and then potentially a predicate checking what's going on, and then an action, how the system responds. You can also see that we have a special marker called requirement, and we're going to come back to that later. Now let's go to the second portion of our model, the QML code, which is where we express what happens on these actions, what happens when the system responds. This is our IDE. If you ever worked in Eclipse, this should be instantly familiar to you. You've seen this windows many times. We distribute our software either as a plugin or as an RCP. And in this case, I'm using RCP. On the left, we've got the project window. We can see that we got our web services demo project here open. And what we're interested in the QML code portion, which is what we're looking at right now. The first thing that we do is we define the interaction between the system under test and the tester. We define two channels, the inbound channel, which is where the user sends stimuli to the system, and then the outbound channel. This is how the system responds. So on the inbound channel, we see that the user can click or request to add a contact, search contacts, cancel, confirm, and so on. And there are two remote commands, remotely add a contact or remotely search for one. And then this is how the system responds. The system can respond with pages only, right? You do a click, and then the system responds with a page. So here's the list of pages that we can potentially see. There is add a contact page, home page, contacts, accounts, and so on. And finally, there are two remote responses, right? Which is what you get when you make a SOAP call. You make a SOAP request, and then you receive a SOAP response. We also need to define what these requests and responses are. So for example, a contact detail. What does a contact detail contain? It contains the email address, two fields for first and last name, association ID, and so on. Now, these were lifted directly out of the SOAP spec for SugarCRM. We looked at the spec and said, what is exchanged between the tester and the system? This contact. And then these are the fields contained in the spec. So we're going to include them into our model and let the engine generate appropriate data for them. In a similar fashion, we define other records. For example, if you request to, in a similar fashion, we define other records. For example, homepage can have title, content, maybe a URL for a certain image, which is what we're going to check when we receive this page. We're going to verify that this image is potentially present there. And then maybe an X and Y coordinates for a certain element on the page.